So this is the same lesson, simplifying square roots, but right here, off of what we did yesterday, it's pretty easy to take the square root of a variable that has an even power, because that just ends up dividing the exponent by 2, right? So what's the answer to the square root of x to the 20th? X to the 10th, right? Now if you want to see the actual work, it's right here on the side. So the square root of x to the 20th, we all know that the square root can be written as the 1/2 power. And we all know from the rules of exponents that a power to a power you have to multiply. So 20 times half is simply half of 20, 20 divided by 2, which becomes 10. So it's really easy to take the square root of any variable that has an even power. So like for example, how about x to the 8th? What's the answer there? Square root of x to the 8th. What's the answer? X to the 4th. Come on, guys. Help me out here. How about x to the 12th? Square root of the x to the 12th. That's x to the 6th. Okay, how about the square root of 9, x to the 2nd, y to the 8th, z? How about that? That's 3x, y to the 4th. And what about that z? You can't do the square root of z, right? So you're going to leave it in there, square root of z. So it's pretty easy to take the square root of a variable with the even-powered exponent, but I want to look at variables that have an odd-powered exponent. So taking the square root of an odd-powered variable is a bit more fun. Okay, so we all know that the square root can be rewritten as what? So the square root could be rewritten as a power of 1/2. So I could write it as parenthesis, power of 1/2, and then put that x to the 5th right in there, right? And we all know that a power to a power, you multiply. What is 5 times half? What is 5 times half? We're going to get x to the what? 2.5, right? Or 2.5. Or you could say 5 halves, but what is half of 5? It's 2.5. What's half of $5? $2.50. So I'm going to say, I want to write it as a mixed number, 2 and 1/2. Now once again, I did multiply 5 times half, right? When you say 5 times 1/2, you end up with 5 halves, which ends up being, that's an improper fraction. As a mixed fraction, it ends up being 2 and 1/2. And that's exactly why we have this 2.5 power. Okay, now we're not going to leave it like that though, okay? This is what we're going to do. We're going to split the base. So what do I mean by that? You guys remember rule 1 of exponents? X to the 2nd times x to the 3rd. What's the answer to that? That's rule 1 of exponents. What's the answer? X to the 5th. Rule 1 says that when you're multiplying with the same base, you're able to add the exponents, correct? Yeah? Okay. Now, what I'm going to do is use that rule backwards. Now, in other words, what I'm saying is, if I had x to the 5th, I could split that up to x to the 2nd times x to the 3rd. I could, if I wanted to. So I'm going to use that rule backwards. So I'm going to use that rule backwards up here, x to the 2.5. Okay, this is going to be weird, but I'm going to rewrite that x to the 2.5. I'm going to rewrite it as x to the 2 times x to the 1/2. Take a moment and think about that. I took this x to the 2.5 and I rewrote it as x to the 2 times x to the 1/2. Because rule 1 of exponents says if you're multiplying with the same base, what do you do with these exponents? What do? You add them, right? And when you add them, you end up with what we had originally, 2.5. Okay? So now it depends on whether the quiz or the homework asks you for the answer in radical form or in exponential form. So if it said write it in exponential form, then yeah, you could leave it like this. But if they say radical form, or if we started with radicals and they don't say anything, you should probably end with radicals. So the answer will be x to the 2nd square root of x, because x to the 1/2 is a square root. Does that make sense? So if you understand that, that's great, because these are skills that you're going to have to use in Algebra 2. Now, is there an easier way? Yeah, there's an actual easier way. You guys want to see an easier way? This is where you say yes?
Yes.
Okay. Going back to this problem, the square root of x to the fifth. Now remember, you could break it down with multiplication to get whatever you want, or what would work better for you. So we all know that x to the fourth would be great, right? Any even powered would be great. So what I'm going to do is I'm going to take that x to the fifth and I'm going to rewrite it as x to the fourth times x. Because x to the fourth times x is really x to the fifth, right? Now, when I split the root, I will have x to the fourth times x. And what is the square root of x to the fourth? X to the second. And the square root of x stays the square root of x. So I think that's an easier way of looking at it. It's really different because we're still working with radicals as opposed to switching to the exponent of 1/2. So here's an example, and we're going to simplify this radical. Now we're going to start with that negative sign. What about that negative sign? What could we do with that negative sign? That negative sign, we're going to put it as an I on the outside. Now we have a regular 6 in there. And let me ask you this before I continue on. Do we like this 6 right here inside the square root?
No.
Yes.
Yes.
It's even. We love even powers because when you divide by 2, but we don't like the 3, right? So now the y, I don't care, even though it's odd. I don't care because it's just going to stay in the root. So I do like the x to the 6th. I'm going to bring that down. The y's fine. But the z to the 3rd, I would like an even exponent there instead of 3. So what I'm going to do is I'm going to split z to the 3rd. I'm going to rewrite z to the 3rd as z squared times z. That way I have an even power. And now what I'm going to do is split the radical to each of the terms, okay? Or at least the ones that I can do. All right, so I have an I on the outside, and then I have the square root of, let me do the ones that I can do. X to the 6th, I could do that. That'll be x to the 3rd. And then the square root of z to the 2nd, I can do that one. And over here, I want to put whatever I can't do. Like the square root of 6, I can't do it. Like this y right here, I can't do it. Square root of y, it's just going to be in the square root. And this z right here, I can't do it. I'm just going to bring it down. Does that make sense to everybody? And continuing, the square root of x to the 6th, that's just x to the 3rd. The square root of z squared, that's just z. The I, I'm going to put it after the letters, after the variables. This I, just put it over here. And then I'm going to bring down the radical 6yz. And that would be your answer right there. X to the 3rd, z, I, square root of 6yz. So if you do have the radical, or the square root of x to the 8th, y to the 7th, what would your answer be? You could split it. Okay, so right here we get x to the 4th. And what about the square root of y to the 7th? Huh? What about the square root of y to the 7th? Okay, see, what's the problem? You have an odd power, right? 7. You don't want an odd power. You want an even power, right? Because it's divisible by 2 if it's even, right? So let's rewrite it. Let's take this square root of y to the 7th and rewrite it as a square root of y to the 6th times y. Make sense? That way you could split the root. The square root of y to the 6th, you could actually do that now. And the square root of y, that just means it's going to stay the square root of y. So what is the square root of y to the 6th? Y to the 3rd. So my answer is x to the 4th, y to the 3rd. That's an ugly y. There you go. It's a better y. Y to the 3rd, and then square root of y. So this is going to help us on our homework on 10.2 WSP. This is number 8. So if you want to simplify this, you're going to split it all up. Now, u to the 3rd is an odd power. What would you like to split it to? What would you rewrite it as? u to the second times u, right? The u to the third, you're going to rewrite it as u to the second times u. Okay, so the 27, you're going to simplify it the way you always do. Break it down, get a perfect square number, 9 times 3. Then you could split the root. So you will have 3 square root of 3, and then times the square root of t, and then times, but let's split that root. So you have u squared and u. And we all should know that the square root of u squared is what? Just u. And of course, we're going to bring down the other square root of u. So whatever's on the inside of the radicals, we're going to put them together underneath one radical. And whatever's on the outside of the radicals, we're going to put them in front of that radical. So out in front, I will have a 3 and a u. And then inside the radical, I will have the 3, the t, and the u. So 3tu. And that is your final answer for this question on your homework. Does that make sense? So whenever you have an odd exponent, all you have to do is rewrite it with rule 1 of exponents to make it look like an even one, and then a separate letter right next to it. And then you could split the root and do it. So this is number 10 on WSP 10.2. Now, of course, we're going to split it up. So let's go the square root of 108. Let's go the square root of x to the 6th. That's easy when it's an even power. Let's do the square root of y to the 4th. That's easy. That's just y squared when it's an even power. But the one that's a little more interesting is the z to the 5th. That's an odd power. So we're going to rewrite it with multiplication. What are we going to rewrite it as? Z to the 4th times z. Because that's the same thing. Z to the 4th times z is really z to the 5th, right? Now, why did I do this? Because this is odd and this is even. I like it even because I could actually divide by 2 when I do the square root, because the square root, after all, is the power of 1/2. So we're going to go through this. Let's do the last part, the z, first. I want to split it, z to the 4th, square root of z. So what is z to the 4th? That's just z to the 2nd. Okay. And the square root of z is still the square root of z. And we're going to put that in the radical answer at the very end. Okay. So let's go to the other ones. This one's super easy. What's the square root of x to the 6th? That's just x to the 3rd. And this one's also super easy. What's the square root of y to the 4th? That's y to the 2nd. Now, the other one that requires a little more thought is the square root of 108. 108 is not a perfect square number. Okay, and how about this? What perfect square number could I actually rewrite 108 as with multiplication? Maybe 4 times something, maybe 9 times something. But if you want to go for the highest perfect square number, I think it's 36 times 3. Am I right? 36 times 3? Yeah. 36 times 3. That'd be the highest perfect square number. So, and of course, you guys have calculators. You could take 108 and divide it by 9. You could take 108 divided by 25. It's not going to work. Take 108 divided by 36. So you could take 108 and divide it by all these perfect square numbers that you should know and see what's the best combo. So 36 times 3. And when I split the root, I will have 6 square root of 3. So this is my answer, but I just need to organize it. What do I mean by organize it? I want to put all the radicals together underneath one radical, and I want to put all these outside values in front of that single radical. So my answer is going to have the square root of what? What's on the inside of the square root, guys? 3? On the inside of the square root. 3 and z. And that's it. What's in the front of the square root? 6, x to the 3rd, y to the 2nd, z to the 2nd. And that's your final answer for number 10.